Class number 7. Welcome one, welcome all. Class number 7 is entitled Parallel Lines, and I'm going to tell you something that's hopefully going to get you nice and relaxed, and that is this week is going to be maybe a little bit of a break compared to some of the materials that we've done in past weeks. And the reason is because a lot of the stuff that we're going to cover this week is stuff that we've already done. For some reason the book, if this is all based on the book, obviously, in terms of the order. This week is Chapter 4, and Chapter 4 is stuff, a lot of the stuff in Chapter 4 was already alluded to in previous classes. So, I don't know if I'd say necessarily that this stuff is easy, but I would say that this stuff is a lot of repetition from what we've discussed earlier in the course already, maybe a little bit of new stuff here and there. But we're going to be discussing some materials, and we are going to be discussing slides. Practice questions, excuse me. Okay, what today we are going to really be looking at is parallel lines and how to discuss or how to figure out angles that are relevant or that are attached to or that are in figures that are relevant to parallel lines. And then on Wednesday, we are going to be discussing quadrilaterals that are based on parallel lines, namely parallelograms and trapezoids. And again, parallelograms and trapezoids are both things that we did cover earlier in the course, so a lot of the stuff we're going to cover is review, which is fine. And by the way, I do want to mention, everybody, that you know what happens after Class 8? That's right. It is party time. It is exam 1 time. That's right, midterm time. If you like, I'll have it posted tomorrow. I don't mind if anybody wants to take it a little early. I don't mind people taking it a little early, especially since we've already covered a lot of the stuff we're discussing Chapter 8. In Chapter 8, the exam will be. Honestly, I forget offhand exactly how many questions I put in the exam, but I am going to look that up for you as I'm checking this right now. I am going to look that up because I really wanted you to know that information, so I apologize for forgetting that information. Okay, that is an excellent question. How do you show your work on the exam? First of all, let me just tell you how many questions are on the exam. Okay, there we go, and we've got 12 questions on the exam. 12 questions, and that are each worth 8 points, and then the last question will be a true or false question that will give you an opportunity to get essentially 4 free points. The last question will basically ask, do you want the last 4 points? And if you say true, you get it. If you say false, you don't get it. So, I definitely recommend true for that answer. So it's 12 questions. Now, as far as how you show your work for the exam, this is what I strongly recommend. While you're doing the exam, take out a pen and a paper and show your work. And for each one, do your work. Put in your answers to the questions. I believe the exam actually gives you the opportunity to submit a PDF. So, for example, if you happen to do your answers in Microsoft Paint, or you do it online, or you want to scan your answer in, you can probably just upload the PDF that way and show it that way. That's obviously a little more complex. If you want to do it the easier way, simply put the answers in the boxes that are, for each question. And things that you want to show your work for after it's over, after the exam is over, either scan it in and email it to me or fax it to me. The fax number is, it's on the website. I forget offhand what the fax number is. It's 866-347 something, 2424. Honestly, I forget offhand exactly what it is, but it's on the website somewhere. It's the general school fax number, and you can send it to my attention. And it is, I'll tell you right now, yes, 866-347-2744. Right, that's the fax number. So you can fax it to my attention, or okay, yeah, and the same thing is true when you're talking about proofs. When you're talking about proofs, if you can do it, theoretically you could do it on the screen. You can do it in a Microsoft Word file and upload, turn it into a PDF and upload that, or you can simply fax it or scan it and email it to me. While I'm grading your exam, I will have your scanned work next to me. I'll print it out, whatever it is. I'll be looking at it. So even if you get the answer wrong, if you showed your work, I can give you partial credit. And I very, very strongly recommend that everybody show your work as much as possible, because, if you get a right answer, if the question is, what's this angle, and you write 37 and the answer is 37, I can give you full credit whether you showed any work or not. But if you write 38, so even though you're very close, if you don't show any work, I got to give you 0 points. I have no choice, because for all I know, it was a guess. But on the other hand, if you show me work and your answer is 417, but then I realized from your work that you got most of it right. You just happened to mess up one little decimal point, and that ended up giving you an answer that was orders of magnitude different. I can still give you, 8 points out of 12, 10 points out of 12, 6 points out of 12, whatever it is, which is, again, a lot better than nothing. If you show me some work, I'll give you partial credit. If you don't show me any work, unfortunately, there's no way that I can really give you extra credit. So I do encourage everybody to please show your work if you can. Okay, first we have parallel lines. Now, we've already discussed parallel lines in the past, but since it's on the slide, we might as well mention it again. Parallel lines means the two lines will never meet. Oh, well, happy birthday. Congratulations. So, yes, please, you can email it to me or you can fax it to me. I definitely recommend email if you can do that. If you can scan it in and email it to me as a PDF, that would be the most efficient. If you can't do that, then faxing will work as well. Okay, parallel lines means lines that will simply never touch each other. Now, remember, a line means something that goes infinitely in any direction. The two things that are, or the two sets of lines that are here on the paper are meant to be lines, and the reason why you know that is because they have arrows in each direction. Arrows means that it goes on forever. A ray, as you'll recall, is something that ends in one direction and goes forever in the other direction, and a segment has two endpoints. Segments can be parallel to each other, rays can be parallel to each other, lines can be parallel to each other, lines can be parallel to segments, lines can be parallel to rays can be parallel to segments. Essentially anything that is like a line can be parallel to something else that is also like a line. Parallel simply means that if you would extend either one or both of them forever in both directions, they would still never meet. Okay. The first rule that I wanted to discuss regarding parallel lines, and again, this is something that we already covered, but we'll cover it again over here, is that when you have a situation like this, where you've got two parallel lines that are over here, and you cut them with a transversal, and all a transversal means is anything that cuts two lines, yes, that should say cut, but any that cuts between two lines, that could be a segment, that could be a ray, that could be a line, whatever it might be, cuts two parallel lines. So lines that are alternate interiors, in other words, lines that are on opposite sides of the transversal, are equal to each other. Okay. Now, lines that are consecutive with each other are supplementary. So if I have two lines, for example, that are parallel, again, these are not actually parallel. So if I've got 1 and 2, those are alternate interior angles. So if this is parallel to this, so 1 and 2 have to be equal because they are alternate interiors. If this is 2, on the other hand, if they're on the same side of the transversal, then they're supplementary, which means they have to equal up to 180. And if you think about it, that's really just a corollary to the alternate interior rule. Because if 1 and 2 are equal, well, what is the relationship between 2 and 3, let's say? Let's say this is 3. What's the relationship between 2 and 3? Well, they're in a linear pair, right? They are a pair of angles on a line. And what do we know about a linear pair? Two angles that make up an entire line, they're supplementary. It means they have to equal 180 altogether. And since 1 and 2 are equal, and since 2 are so by the chain rule, we can deduce that 1 and 3 are supplementary. So angle 1 plus angle 3 equals 180 degrees. On the chart over here, on the graph, on the slide, C and A are supplementary, C and B are equal, A and D are equal, and D and B are supplementary. Okay. How about something like this? Let's say, once again, you've got two parallel lines, or rays, or whatever they happen to be. Let's cut them with a transversal. Let's make the transversal look something like straight. Okay, that's close enough. And let's say you want to figure out the relationship between, let's say, 1 and 2 over here. Well, this is obviously something that you really have to do in 2 steps. You can't do it all in 1 step because they don't have any direct relationship with each other. Now, Tavor is correct. They're equal. And the reason why they're equal is because of, essentially, a chain rule with two other angles. Let's say angle 3. What's the relationship between angle 1 and angle 3? The answer is that they're equal. Why are they equal? Because they're vertical angles. Vertical angles are angles that are cut. When you have two lines that cut that crisscross each other, opposite angles are equal. And angle 2, of course, is equal to angle 4 for the same reason. They're vertical angles. Now, angle 4, sorry, is equal to angle 3 because they're alternate interior angles. Therefore, since angle 1 equals angle 3, and angle 2 equals angle 4 because they are vertical angles, and we also know that angle 3 equals 4 because they're alternate interior angles, so therefore, if we take that together, we know that angle 1 must equal angle 2 because of the chain rule. Okay, how about the relationship between 1 and 5? What's that sort of relationship? That's supplementary. That's right. And there are many, many different ways you could figure that out. You could figure it out because 5 is supplementary with 4 because they're a linear pair. And 4 has to be equal to 3, which has to be equal to 1, which means 4 has to be equal to 1. So since 5 has to be equal to 4, which is 5 has to be supplementary with 4, it also has to be supplementary with 1. You could also figure out that 5 is supplementary with 4 because 2 and 5 are supplementary and 2 and 4 are equal. In other words, when you have these complex problems, like a particularly fun problem, I think at least, homework assignment number 1, assignment number 4, number 1, where there are 28 different angles, you'd be amazed how quickly they fall once you start getting 1 or 2. You think there are 28 different angles. Boy, that's like a crazy number of angles, right? And I'm only giving you 2 of them. I only gave you angle 28 and angle 8. And again, I'll put it up later on. Maybe we'll take a look at it. But the thing is, you'd be surprised how quickly they fall. You get a couple of them, and all of a sudden the rest of them fall. The rest of them fall pretty quickly. Okay. So, okay, good. Well, that's very good. Okay, so that's alternate interior and angles. And the opposite is true as well. Until now, we've been discussing that once you establish that lines are parallel, well, you can now establish that the alternate interior angles are equal. Well, you can also do it the opposite. If alternate angles are equal, alternate interior angles are equal, then the lines, by definition, have to be parallel. Close enough. All right, so if I tell you that angle 1 equals angle 2, that tells us that this line is equal to this line. Not equal, excuse me, that this line is parallel to this line. Another rule that's on the slide over here is that if two lines are cut by a transversal that is perpendicular to both, the lines have to be parallel. Now, perpendicular, of course, means forming right angles. So if we have two lines, and we have a transversal that forms right angles with both, then by definition, these lines have to be parallel. This is not really a separate rule from the ones that we've already been discussing. It's really the exact same rule. Does everybody see why it's the exact same rule as the alternate interior rule and the rules that we discussed last slide? Think about why. Let's put numbers on the angles. 1, 2, 3, 4, 5, 6, 7, 8. Okay, what's angle 1? This is going to be an easy one. What's angle 1 here? 90 degrees. What's angle 2? 90 degrees. What's angle 3? This is going to be repetitive. Okay, Devor's just going to type 98 times in anticipation of my question. And that's correct. All 8 of them are going to be 90 degrees. Why is that? Well, let's figure it out. A right angle, a perpendicular line makes a right angle. Now, if this is 90, well, then 4 also has to be 90 because it's a linear pair. And these 2 and 4 have to be supplementary. 3 also has to be 90, either because it's a linear pair with 4, so it's supplementary with 4, or because it's a vertical angle with 2, which is 90, so it has to be equal with 2. 1 is 90, either because it's supplementary with 2, or because it's supplementary with 3, or because it's equal with 4. And of course, 6, 7, 5, 6, 7, and 8 have the exact same logic, and so they're 90s as well. So, based on this, are alternate interior angles equal? Alternate interior angles are equal. What are alternate interiors? Who can give me 2 pairs of alternate interior angles here? 4 and 5 are alternate interiors, okay. What else? Who can give me another pair of alternate interiors here? 3 and 6 are alternate interiors, and they're equal. If alternate interiors are equal, that means the lines are parallel. Also, if consecutive angles are supplementary, then the lines are parallel. Who can give me 2 pairs of consecutive angles? Okay, 3 and 5 are consecutives. Good. What else? 4 and 6. Very good. And are they supplementary? The answer, of course, is that they are supplementary. So this rule over here, that if 2 lines that are cut by a transversal that's perpendicular to both the lines are parallel, it's really just a corollary to the alternate interior rule that we discussed previously. All right, let's have a little fun here. Find all of the angles that are findable. How do I get this? Here, this thingamabob over here. All right. Does this thing work over here? All right. So, good. Okay, so these two are parallel. Those two little things are arrows. And we're going to find as many angles as we can. All right. We've got this thing over here, by the way, is that's alpha. And then we got beta in the lower right-hand corner. We got x over there. Let's figure out some of the angles that we can figure out. Let's see how many we can get. And you'd be surprised. We're going to be able to get a lot of them. All right. First of all, can we figure out angle beta? The one in the lower right-hand corner of the triangle. Okay, alpha is 56. But let's talk about beta first. What's beta? The one in the lower right-hand corner. How would we figure it out? 65. Good. Why is it 65? Who can tell me why it's 65? What rule did you use to figure out that beta is 65? It's a linear pair with 115. And the linear pair with 115 means that it has to be supplementary, and 180 minus 115 is 65. Okay, good. Now, Devorah says that alpha is 56. Why is alpha 56? What's the logic that alpha is 56? Okay. Okay, alternate interior and then vertical? Okay, in other words, what you're saying is that, well, right, okay, in other words, this one is 56. Sorry, it's a little small for me to write it out. Right, okay. Yeah, so either way, so that's this angle is an alternate interior with this 56, because these two lines are parallel. And once this is 56, I'm just going to write it up here and put a little arrow in here, because otherwise it's hard to see. And then of course it's vertical with the x. Exactly. Or you could have used the 56 and this over here as supplementary. What's that angle? The one with the longer arrow that I just put in. That's supplementary with the 56, which means it's 180 minus 56, which makes that, of course, 124, right? Because it has to be supplementary with the 56. Okay. What about angle x? Okay, angle x is 115 minus 56 minus 65, 180, sorry, 180 minus 56 minus 65. And there are two ways you can get that. Number one is that way. It's a triangle. The interior over here is a triangle. So a triangle has to equal up to 180 altogether. Then there's, of course, the exterior angle rule, which says that the exterior angle, which is this one, has to equal the two interior angles added to each other. So 115 equals 56 plus x. So 115 minus 56, which is, of course, 59. So we're going to say the x is 59. And again, we figured that out either because it's 180 minus 56 minus 65, and or because it's 115 has to equal x plus 56. Either way, it's 100 and it's 59. Okay. What other angles can we get? Can we get the third angle in the triangle? That's a little bit more complex. Well, I guess there is the bigger triangle. How about this angle here? How about that angle? Can we get that angle? I'm not sure. um, hmm. Yeah, maybe not. Maybe there is no way to get that angle. This is 115. Yeah, maybe not. Well, we can get this angle here. We'll call that angle C. Yeah, that we can get because of this. It's like it's in this bigger triangle. The bigger triangle flanked by this side, and this side. So the bigger triangle is 56, 65, and also 59. So this must be 59 over here as well. And what about the other side? The other side... Yeah, I don't know if we can get this one down here in the lower right hand corner here. Yeah, maybe not. Anyway. Okay, so, and now of course there are other angles we can get, obviously. We can get this angle over here as being 180 minus 6, which is 124. Yes, it does have to be less than 65. But this we can get as 121. Go to supplementary with this. Alright. Let's try another one. Let's try this one here. Let's try getting all of the angles here. And there's a whole bunch of angles here, but this is actually fairly comparable to angle 1. It's angle 1 on the homework. So let's start with the lower right-hand side of the page. Based on this 50, what is... Yeah, well, let's assume that... Yeah, so, I mean, these have arrows. So generally speaking, if you see arrows, we can assume that they're parallel. So these lines are all parallel. So now we got to figure out what all the angles are. Okay. Well, can we get this one first of all? The one next to the 50. That's supplementary with the 50 because it's a linear pair. So we're going to make this into 130, right? Once you have that 130, okay, I guess I can number the angles. It's not a big deal. Alright, so let's name them angle 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so let's figure out all our angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 11, 12, 13, 14, 15, 16. Okay. There we go. Okay, angle 1. Well, actually, let's start at the bottom. We can start with angle 1, which is all the way on top. Okay. Yeah, angle 16. Good. So angle 16 we can get as 50 because it's vertical with the 50. Good. Okay, very good. Okay. So can we get 17 and 20? Yeah, 17 and 20 are going to be each 130 because they're supplementary with the 50, with each one with their own 50. So that's going to be 130 degrees. Okay. Now, can we get, at this point, we can't really get 14, 15, 18, and 19 yet. Although we can get it from the 110, really. But, okay, actually we can. So let's fill out with the ones with the 110s. How about the one next to 110? How about number 7? Angle number 7 is what? Angle number 7 is 70 degrees. That's right, because it's a linear pair with the 110. Angles 10 is what? 10 is also 70, either because it's supplementary with the 110 or because it's vertical to 7. And angle 11, of course, is 110. Good. Okay, now let's try 8, 9, 12, and 13. Well, what's 13? Okay, 13 is the same as 16 because it's alternate interior with 16. That's right. And 16 we knew was 50, so 13 has 50 also. So 13 gives us also 8. 8 is a vertical angle with 13, so that's also 50. How about 9 and 12? 9 and 12 are what? Nine and 12 are supplementary with 8 and 13, so they're 130 each. Okay. About 14, 15, 18, and 19. Okay, what's 14? 14 is alternate interior with, right, 14 is an alternate interior with 11. And 11 was 110, so we'll make that 110. And then, of course, 19 is a vertical with 14, so we'll make it also a 110. And 15 and 18 are going to be 70 each. For the same reason, they're entry with the 110s. Okay. Now we get to the top 6 over there. Okay. What can we figure out between 4, 5, and 6? And the truth is, we can get 4, 5, or 6 now. You can get 4 as 70. How'd you get 4 as 70? You got 4 as 70 as an alternate interior with 7, right? 4 is alternate interiors with 7, and 7 was 70, so 4 also has to be 70. 6 is alternate interiors with 8, and 8 was 50, so 6 has to be 50 as well. Good. How about 5? Now, there are a few different ways you can get 5. 5, either you can get... By the way, what do 4, 5, and 6 have to add up to? 180, because exactly, it's a line. It's not a linear pair. It's instead like a linear a linear I don't know. What's the word? What's the word for 3 when in trio? A linear trio. Yeah, okay, so it's a linear trio. But it has to be 180 altogether. Or, by the way, you can get it because it's a triangle with 7 and 8. 7, 8, and 5 are a triangle. They have to equal 180. Or, it's a triangle with 15 and 16 and 5. 5 is a triangle with 15 and 16. Either way, 15 and 16 are 50 and 70. 7 and 8 are 50 and 70. 4 and 6 are 50 and 70. So either way, they're supplementary with 50 and 70, which is 120, which means it's 180 minus 60, which of course is 60. Okay, so what about 1, 2, or 3? Well, you can get 2 because it's vertical with 5, so that's 60. You can get 1 because it's vertical with 6, so that's 50. And 3 because it's vertical with 4. And of course, you can get it many other ways. You also could have gotten 1 because it's a it's a linear trio with 2 and 3, or a linear trio with 1 and 3, etc., etc., etc. And now you get all 20 of them. So that's kind of like what the first homework the first homework question is. So it's kind of similar, not quite the same thing, but fairly similar. Okay. A couple of other things regarding regarding triangles. Now, we already discussed this a little bit, but we'll discuss it quickly again. One is the exterior angle rule. If you'll recall, the exterior angle, which again I just mentioned a few minutes ago. Let's assume this is a line. Yeah, I wish. Okay, that looks a little better. So if this is A, and this is B, and this is C, the exterior angle says A equals B plus C. An exterior angle of a triangle, which means the continuation of a line outside the triangle, equals the other two combined. And of course the reason is very simple, because let's say we transposed it with D over here, and D has to be supplementary. So if A and D have to be supplementary, and of course D, B and C have to be supplementary because they have to equal up to 180 because they're all part of a triangle. So since we know that A plus D has to equal 180, and we also know that B plus CD has to equal 100, well, the D's cancel because the D's are the same. So A has to equal B plus C. That's the exterior angle rule. We already discussed the congruent triangle theorems in the earlier. I'll quickly go over them. The congruent theorems, how you know two triangles are congruent to each other. The first one, congruent to SSS, which is equal to this, and this is equal to this, and this is equal. I'm sorry, this is equal to each other, and the ones are equal to each other. That's equal. We had SAS is congruent to AS because it's like this. This is congruent to this, and this is this, and the angle in the middle is equal to each other. Well, then the two triangles are congruent to each other. And we also had two angles and a side. That could be if the side is in between the angles, then it would be called ASA is congruent to ASA, which is something like this. If this is angles equal to that angle, and this angle is equal to this angle, and this side is equal to this side, so that's angle, side, angle. And there's also AAS is congruent to angle, side. So if we have two triangles, if this is equal to this, and this angle is equal to this, and then you have this side is equal to this, that's good enough as well. That also makes the two things congruent to each other. Then we have the high leg rule. The high leg rule is a rule that in a right triangle, two right triangles, and this only works if they're right triangles, okay, well, these triangles don't look too congruent to each other, so you're just going to have to take my word for it. If the hypotenuse and one of the legs are equal, in other words, the hypotenuse is equal to that hypotenuse, and let's say this side, this leg is equal to this leg, so we know the two are congruent. Even though this normally would be an SSA side-side angle wouldn't work. But in this case, because it's a right triangle, there's a special rule that in two right triangles, hypotenuse plus the hypotenuse plus Either leg. Yes, that's right. I know last time I used a slightly more colorful term for it, but all right. Okay. Now, the last rule I wanted to discuss before we looked over some practice questions over here is the bisector of an angle rule. A point is on an angle bisecting and an angle bisecting the line if and only if it is equidistant from the sides that make up the angle. So, if, for example, we have this, well, I got the diagram over here for you, where you have BAC is an angle, and AD is a ray in this case, because it's going on forever in one direction. If DB is equal to DC, that also means that the line AD, or line segment A, or ray AD, bisects angle BAC. Which means that the two angles that are equal to each other are angle B is congruent to DAC. The angle. As a side, the rule that this depends on, which hopefully will be fairly obvious to everybody, is that the shortest distance between two lines has to be a line that is perpendicular to one of them. Actually, really, it has to be, well, let's put it this way. Let's say you have two lines like this. A bisector, I'm sorry, not any lines, but a bisector. Something like this. If I take any given point on this middle line over here, and I want to draw the shortest possible line segment to either line, or to both lines, that line, that shortest possible line, is going to be whatever is perpendicular to this other line, to the sides. So if this is A, and this is B, and this is C, and C, like in the diagram. So if I want to draw something from AD to AC, the shortest possible distance is going to be what's perpendicular to this. And by the same token, if I want to draw it to AB, excuse me, from AB to AD, the shortest possible is going to be what's perpendicular to that as well. And I'm sorry if I'm not drawing that very well. Okay, I didn't draw this very well. But, okay, whatever. Anyway. That's why in the diagram over here on the slide I made right angles at angle ABD and angle DCA. So, but in other words, if that line is equidistant, if the AD is equidistant from AB and AC, then the interior lines are going to be equal as well. Okay, and I think that's fairly intuitive anyway, just by looking at it. Okay, what I wanted to do next is to look at some questions where we're going to use algebra to figure out the line. I'm going to do screen sharing here. Okay, just give me 1 second. I think I remember how to do this. Alright, I'm going to put this here, and then I'm going to do this. Oh, no problem. That's all right. Okay, can everybody see my my browser over here? You should be able to see my empty Microsoft Paint, my blank Microsoft Paint window over here. Okay, good. All right. Let's say we have something like this. Hey, I'm sorry, 1 second. Ah, there we go. All right, there we go. Let me just get the pen over here. Okay. Let's say line M is parallel to line N, and we want to know all the angles. Let's number them. Let's say this is 1, 2, 3, 4, 5, 6, 7, 8. And we're asking you to find, remember, once we get one of them, it'll be easy. Much easier than the problem that we did before, that we were able to get without much of a problem. So how would we do this from an algebraic perspective? What do we know about the relationship between the two angles that are given to us? What's their relationship between the 2x minus 10 angle and the 65 minus x angle? The answer is they're equal to each other. Why are they equal to each other? Because they're alternate interiors, right? The two lines are equal. Good. So that means we can set this up as a very simple algebraic equation, saying 2x minus 10 equals 65 minus x. Now, hopefully you all remember this. If you don't, the way you solve this is you have to isolate x, which means you try to get all the x terms to one side and try to get all the numerical terms to the other side. So let's take the x term from the right side, get it to the left side, so we can do that by adding x. If we add x, since this is a minus x, we can cancel these. And in any algebraic expression, whatever you do to one side, you have to do to the other. So we can add x to this side as well. Now we can combine the x's. 2x plus 1x is 3x minus 10 equals 65. And I see Devorah did it all in one step, and that's fine. But for the time being, let's try to do it in multiple steps. Once we have this, we further want to isolate x as well. So the way to isolate the x term is by getting rid of the number term. And the way to get rid of -10 is by adding 10. And whatever you do to one side, you have to do to the other. So you have 3x equals 75. Now, since you have 3 multiplied by x, the way to get rid of the 3 is to divide by 3. And once you divide this side by 3, you divide this side by 3, and you have x equals 25. Now you can just go ahead and figure out what each one is. Well, 2x minus 10 is 2 times 25, which is 50, minus 40, minus 10, which is 40. 65 minus 25 is also 40. They had better be equal, by the way. If we figured out that 4 and 5 are not equal, it means we've got a problem, because we know they're equal because they're alternate interiors. Now, once you have that, you can get the rest relatively easily. 3 is supplementary with, so that means 3 is 180 minus 40, which is 140. 2 is 40 because it's vertical with 4. 1 is vertical with 3, so it's also 140, and so this is also 140, 140, and away you go. Okay, easy enough. Let's try another one. What's going on over here? Okay, okay, that was very nice of Snagit to give me a lesson on how to use it. But thank you. I know how to use Snagit, but I appreciate the lesson. All right, there we go. All right. What do we do now? Well, first we have to figure out the relationship between the 2x plus 10 and the 86 plus x. How do we figure out that relationship? They're equal to each other. Why are they equal to each other? Well, we know that the 2x plus 10 has to be equal to the b angle. Well, yeah, we can use right. Okay. I mean, you can use it in a few different ways. You can say that this has to be equal to b because they're vertical, and then b, let's say for example, has to be equal to d because b and d are alternate interior, and then d and the 86 plus x have to be equal to each other because of verticals. So we know that 2x plus 10 equals 86 plus x. Let's do this equation in the exact same way. We can subtract x from this side and x from this side. You want to get rid of all the x's from one side. 2x minus x is plain x, plus 10 equals 86. And then you want to get rid of the 10 from each side, so you have x equals 76. So, no, that can't be. Yeah, it can actually be. Okay, yeah. So 86 plus x is 86 plus 76, which is 162. 2x plus 10 is 2 times 76, which is 152, plus 10, which is 162 as well. And so, of course, b is also 162, so d is also 162, and the rest are supplementary with that. So the rest are 18. Okay, let's do one more, even though these are quite easy, but we'll do one more where we have to do it slightly differently. All right. Okay. All right. Okay, what is the relationship between these two angles? These are consecutive angles, so they're supplementary. Very good. So how would we write this equation? If we wanted to write this algebraic equation to express the relationship between these two, how would we write them? Add them up, and they have to equal 180. So we can write this as 3x minus 10, oops, not 12. Really, technically speaking, you should really put it in parentheses, plus 5x plus 30 equals 180. Now, I can, in this case, I can just open the parentheses because adding a parentheses is the same thing as just adding all of the component parts of it. So here we can just open the parentheses and say 3x minus 10 plus 5x plus 30 equals 180. Now we should combine like terms. We've got a 3x and a plus 5x, so we'll turn that into an 8x. We've got a negative 10 and a positive 30, so we can turn that into a positive 20 equals 180. Now we can isolate the 8x, subtract 20 from each side to get the x term by itself. So we've got 8x equals 160, and here we need to isolate the x by dividing by 8 to get rid of the 8 because it's 8 times x, and so x equals 20. All right, let's figure out the angles. 3x minus 10 is 3 times 20, which is 60, minus 10, which is 50. 5x plus 30 is 5 times 20, which is 100, plus 30 is 130. And again, let's make sure they're supplementary. They better be supplementary because they're consecutive angles, and of course they are. 130 plus 50 is 180. So this is 50, either because it's supplementary with the 130 or because it's alternate interiors with the 50. This is 130, this is 50, 130, 130, and 50. And away you go. All right, was there anything else here? I thought there was another type of question. I'm just trying to find it. I have so many windows open here. All right. Okay, you know what? Let's just answer these questions together. Random places. I just Google them. I just Google parallel line problems, and just there's like thousands of them scrambled all around the internet. So we just find a few here and there. All right. Excuse me. All right. Let's answer these and see how good we are at these. Okay. In the following figures of two intersecting lines, what is the? This isn't easy. This is a joke. What's angle 2? Well, obviously, angle 2 is 142 because it's vertical, right? Okay, it's vertical with the 142, so it's also 142. What is the value of x in number 2? It's 5x minus 10, and the 60 is across. Well, what does that mean? That means that 5x minus 10 equals 60. So if you do 5x minus 10, exactly, then you'd add 10 to each side, so you get 5x equals 70. Then you divide each side by 5, and you get x equals 14. Good. Because again, if you solve that equation, you just get x equals 14 relatively quickly. So, let's answer them. Yeah, let's fill in that here, fill in that here. Boy, I hope we get 100. In the following diagram, okay, okay, fine. 5x plus 35. What is the measure of angle 8? Okay. First of all, what's 8? Okay, well, I guess we'll worry about the x later on when we have to worry about it. But what's angle 8? Angle 8 is next to the 45. It's supplementary with the 45, right? Because it's a linear pair with the 45. So, okay, but what's 8? 8 is 135, good. What's the angle of measure 3? Well, 6, of course, has to be 45. And 3 is alternate interiors with 6. So 3 is also 45, good. What's the angle of measure 6? Well, that's alternate interiors with 3. So that's 45 also, of course. What type of angle pair is 1 and 5? Their corresponding angles. Yeah, we didn't actually discuss that, but corresponding angles, I guess, when they're... I know they're not any of the others. They're not alternate interiors because they're not interior. They're not supplementary because they're equal to each other. They're not alternate exterior angles because they're not alternate. They're on the same side of the transversal. They're not verticals because they're not opposite each other. Corresponding angles are where they're on opposite sides, or where they're consecutive on the same side of the transversal. What about angle 2? What's angle 2? Well, angle 2 is vertical with angle 3, right? And angle 3 we said was 45, so that's also 45. What type of angle pair is 1 and 3? They're a linear pair, so they're supplementary. Very good. What's the value of x? Right, 5x plus 5 had to equal angle 5. Angle 5 we discussed before was 135. Subtract 35 from each side to get 5x equals 100, which means x equals 20. Good. What are the values of the two angles shown below? How would we solve this one? They're what? They're supplementary, right? 3x and 12x minus 30 is supplementary. So we'd have 3x. Let me open Paint a little corner here so that we can do this. 1 second. Let me scramble this around a little bit just so that we can... do this out. Okay. All right, so we got 3x plus 12x minus 30 equals 180 because they're supplementary. They're a linear pair. So that means 3x plus 12x is 15x minus 30 equals 180. Isolate x by adding 30 to each side to get rid of the 30 from that side. So we got 15x equals 210. Okay, no problem. So x is 210 divided by 15. 210 divided by 15 should be 14. 14, yeah, I believe 14. Good. Because 150 divided by 15 is 10, and then there's 60 left over, and 60 divided by 15 is 4, so it's 14. Good. Okay, so x is 14. So what's 3x? On this side is 3 times 14, which is 42, and that means the other side must be 180 minus 42, which is 138. Okay, good. So let's try 42 and 138. What's the measure of the complement of 62? That's a pretty easy one, just 180 minus 62. That doesn't seem too difficult. All right. Which of the following is always true when the lines are cut by a transversal? The sum of the degree measures of corresponding angles are 180? No, remember, corresponding angles are on the same side of the transversal, on the opposite side of the line, so those are actually equal. The sum of the degree measure of complementary angles is 180. No, complementary angles are 90. Angles in a vertical pair are acute. Not necessarily. Remember, acute means under 90 degrees. Vertical angles could be obtuse or right angles. Corresponding angles are supplementary. That is incorrect. Corresponding angles are congruent. That is correct. Corresponding angles, again, just to remind everybody, we're like 1 and 5 are corresponding angles. So they're congruent. Okay. In the figure below, which angle is supplementary to angle 8? Well, not angle 5, that's equal to 8. But 3 is supplementary with 5, so 3 has to be supplementary with 8. That's right. Using the figure below, which statement is true? Now, it looks like we've got a perpendicular line. AB is perpendicular to BC. And we have D cutting it. ABD is congruent to DBC. I don't see anything that proves that. It might be true, but we have no real way of knowing that from the diagram. ABD, this angle, and DBC, this angle, are and ABC are adjacent. No, I mean ABC includes ABD as a smaller angle, but they're not adjacent. Which two are adjacent, by the way? ABD is adjacent to DBC. That means they're next to each other. What about the third one? ABD and DBC are complementary. That is true, because this angle and this angle have to equal up to the whole ABC, and the whole ABC is 90. So they're complementary. Okay, what is the value of x? Well, they equal up to what kind of an angle altogether? They equal up to a right angle, right? So they have to equal up to 90 altogether. So we can say 4x plus 40 plus 6x minus 20 equals 90 altogether, because they altogether equal up to a right angle. So let's figure that out. 4x plus 6x is 10x. 40 minus 20 is positive 20 equals 90. Subtract 20, subtract 20. 10x equals 70. So x equals 7. So 4x plus 40 equals 28 plus 40, which is 68. And 6x minus 20 is 42 minus 20, which is 22. And of course, check to make sure that they're supplementary, whether they're complementary, and of course they are. You add them up, they equal up to 90. So the value of x is 7. Okay. Which of the following statements are true? ABD and DBC are a linear pair. Yeah, that sounds about right. It's true there's another line thrown in the middle, but that is true. ABD and DBC are supplementary, so yeah, I mean, I'd say right away that's true. Okay. All right, should we finish these? How many more of these are there? All right, I think we can stop. You know, I'm going to give you this. Hopefully, I think we're right. Just if you want to make sure that, you know, it's. You know, let's finish these up. I think we can finish these up quickly. We still have a few minutes left. All right, so let's do these. So, where were we? Okay. What's the measure angle of ABC? Okay. Well, these are vertical angles. So if they're vertical angles, they're equal to each other. So, oh, I'm sorry. I didn't even see all of the above is true. Let's see, are the rest true? ABE, yeah, and EBC are adjacent. So I know that the second one is true. So if the first two are true, they all have to be true, because that's the only way it makes sense. Okay, what's the measure angle of ABC? So that 3x plus 33 equals 4x plus 8. Well, no problem. Let's say subtract 4x from each side. So you got negative x plus 33 equals 8. Subtract 33 from each side to isolate the x. So you got negative x equals negative 25. divide each or multiply each -1, so you can just make them both positive. So x is 25. So the measure of ABC is 3 times 25, which is 75. 75 plus 33 is 108. Which of the following is true about the figure? Well, let's see. DBC measures 180. It's a straight angle. Yeah, I mean, that's true. BAC. BAC? Huh? That's not an angle. I don't even know what that is. That's not even an angle on the diagram. CBA and ABD are supplementary. That's true. And so choices A and C are true. Okay. Value of the two angles. Okay, let's get our paint back up here. Okay, what's the relationship between them? They're supplementary, right? So 3x plus 25 plus 2x equals 180. 3x plus 2x is 5x plus 25 equals 180. Subtract 25 from each side, and you got 5x equals 155. So x equals 31. So 2 times 31 is 62. So if the 2x is 62, the other one has to be 118. What's the value of x? 3x minus 100 and x. Okay. Well, that means they have to equal each other. So 3x minus 100 equals x. So we can subtract 3x from this side, subtract 3x from that side, and you have negative 100 equals negative 2x. Divide each side by negative 2. And we have x equals positive 50. Okay, so the value of x is 50. Diagrams cut by the transversal. Okay, which of the following statements is false? 3 and 4 are verticals? That's false. Right? They're supplementary. They're a linear pair. 5 and 8 are corresponding? That's false. They're verticals. 3 and 5 alternate interiors? They're consecutive, so all these are obviously going to be false. What's the measure of angle 2? What's the relationship between these two, by the way? Between the 5x plus 5 and the 2x plus 100, they're corresponding angles. So they're equal. So we'll say 5x plus 55 equals 2x plus 100. I know I'm going a little over time now, but we'll do this quickly. Subtract 2x from each side to get that. So we got 3x plus 55 equals 100. Subtract 55 from each side. So you got 3x equals 45. Divide each side by 3, so you got x equals 15. And so 2x plus 100 is 130. 5x plus 55 is... One second. All right, 2x plus 100 is 130. Yeah, 5x is 75. 75 plus 55 is 130. Okay, good. So those two are 130, which means that angle 2 is supplementary, so angle 2 has to be 50. Which of the following is always true? Supplementary angles are both obtuse. That's not even possible, because obtuse means over 90. If they're both over 90, then they can't equal up to 180. Complementary angles are both acute. Oh, that seems true, right? Complementary angles have to equal up to 90. They have to both be less than 90, and acute is less than 90, so that's true. Okay. Why is 3 incorrect, by the way? At least one of the angles in a supplementary pair is obtuse? That's false because they could both be right angles. They could each be 90. Alternate interiors are both obtuse, not necessarily. Only two angles are any two cubed. Oh, that's ridiculous. Okay, what's the value of x? Well, what's the relationship between the 15x minus 3 and the 75? They're supplementary. Right? The reason why they're supplementary, of course, is because this is equal to this, and this is supplementary with this. So 15x minus 30 plus 75 equals 180. Negative 30 plus 75 equals positive 45 equals 180. Subtract 45 from each side. 15x equals 135. So you got each side divided by 15, and x equals 9. Okay? Very good. Two angles are a linear pair. They're measured by x plus 10 and 3x plus 10. Linear pair is what? What's the relationship in a linear pair? Linear pair have to equal up to 180. They're supplementary. Good. So we got x plus 10 plus 3x plus 10 equals 180. X plus 3x is 4x. 10 plus 10 is 20 equals 180. Subtract 20 from each side to isolate the x. So you got 4x equals 160. Divide each side by 4, and you have x equals 40. And the two angles, so x plus 10 is 50, and 3x plus 10 is 130. So that should be this one. Okay, you think we got them all right? Did we fill them all in? Okay, I hope so. Well, let's find out. What? We got answer 11 wrong. Where was 11? Oh, that's right. That's right. Careless error. Careless error, Stephen. Careless error. Everybody see my careless error? What did I thought that said? What did I read that as? What word did I read that as? Supplement! That's right, I read it as supplement, when in fact it was complement. Complement, that means they have to equal up to 90, not 180, which means it's 28. And now we should have 100. Okay. There we go. Anyway, I kept you a little bit of overtime, but hopefully that'll be okay. Actually, I see we lost a few people. We have to go at the top of the hour. That's fine, no problem. All right, next time we're going to be looking at parallelograms and trapezoids and stuff like that, and then we'll be ready for Thanksgiving, and we'll be ready for exam number 1, not necessarily in that order, although it's completely up to you. So have a wonderful evening, everybody, and I'll see you on Wednesday.